Guys, welcome to this video in our YouTube channel. In this video, friends, we shall be looking at the method of integration called the U substitution. Before that, guys, please subscribe to this channel so that you're going to have access to all our great content, guys, and press the bell icon to get notified each time we have new videos. Great. Friends, let's look at the most elementary parts of calculus that we are going to be using. Let's set up a table, guys. We are going to take about 30 seconds to look at that. Let's say we have the function parts. We have differentiation, we'll be differentiating, and here we're going to be integrating, guys. Like I said, guys, it won't take more than 1 minute. Great. Let's assume that, let's make a table, guys. Let's assume that we have a function such as y equals to x to the power n, guys. Differentiating that gives us n, x to the power n minus 1. Integrating that gives us n, gives us x to the power n plus 1 over n plus 1 plus c. Great. Let's take one example, guys, just one. Let's say we have y equals to x raised to the power 4. Differentiating that gives us 4x raised to the power, 4x raised to the power 4 minus 1. That gives us 4x cubed. Integrating that, guys, gives us s raised to the power 4 plus 1 over 4 plus 1 plus c. Simplifying gives us 1/5 x raised to the power 5 plus c. Great. What if we have a function such as y equal to sine x, that is straight functions? Differentiating that, guys, gives us positive cosine of x. Integrating sine x gives us negative the cosine of x plus c. Great. That's what we have, friends. What if we have a function such as y equal to the cosine of x? Differentiating that, guys, gives us what? Negative sine of x. Integrating that, guys, gives us positive sine of x plus c. What if we have a function, guys, such as y equals to the tangent of x? Doing differentiation, guys, gives us sec squared of x. Integrating tan x, guys, gives us something different, such as the natural log of the absolute value of secant x plus c. What if we have a function such as y equals to the natural log of x? That therefore implies, guys, differentiating this one gives us what? 1 over x squared. And friends, integrating natural log of x, we have something different as well. We have x, natural log of x minus x plus c. Great. That's what we have, friends. An important note. Take note about what we're about to do to look at now, friends. Take note. It's super important, guys. Let's ask, what is the integral of 1 over u du, guys, where this u is a linear function? What is this integral, guys? It gives us from what we have here, right? This is it. We want to integrate this. Let's assume that our x is u. Want to integrate this guy. Just that it brings us back to the natural log of x. Wait. So this gives us the natural log of the absolute value of u plus c. The reason for this absolute value sign, guys, is to make sure that this u is not negative, since the natural log function is not defined for negative numbers squared. What if we have the integral of 1 over 1 plus u squared du? This just gives us what? The arctangent or tan inverse of u plus c. Great. That's what we have. So, friends, what if we also have the integral of 1 over the square root of 1 minus x squared dx? This gives us what? The sine inverse of x plus c. What if we have a function such as y equal to e raised to the power x, guys? Keep in mind, guys, take note. It's super important. Therefore, guys, if we want to differentiate this guy, dy by the s gives us what, guys? E raised to the power x. Great. So e raised to the power x, whether you differentiate or integrate, guys, it never dies. That therefore implies, guys, if we want to integrate our e raised to the power x, keep in mind that it never dies. Integrating e raised to the power x, guys, we still have the same e raised to the power x grade. That's super important, guys, super important. So for instance, let's generalize. Generally, if we have a function such as y equal to e raised to the power a function, then, guys, dy by dx, or that therefore implies dy is equal to what, guys? We are going to have the function repeating, then we multiply the function by the derivative of the power, which is f of x. We have dx squared. That's it, guys. That's super important. Then, guys, to integrate f e raised to the power f of x, we are simply going to, here we multiplied, right? In this case, we're going to be dividing. Great. So we have that. All right, friends, thank you so much. And let's look at now the major reason for this video today. Great, friends, great. Okay, now let's look at the key points and hints to always take note when using this method, guys. Let's assume that, okay, friends, for the u substitution method, guys, we want to have two functions in which one is the derivative of the other. Friends, note, I didn't say that one is the exact derivative of other, guys. I didn't say so. All right, that's the first point, guys. The next point, guys, if this is the case, guys, then we are going to let our u to be the function whose derivative gives the other grade. And, guys, In the case of a fraction such as f of x over g of x, guys, we want the derivative of this our function. We want the derivative of the denominator, guys, to rather give us the numerator. Great, guys. Then, friends, in the case of exponential functions such as h of x e raised by f of x, guys, we want the derivative of the exponent to rather give us the function multiplying the entire function and not the necessarily reverse. Great. So, friends, I think we'll just list out all these points. Those are important points that you should take note. Then, friends, let's note this important issue. But before then, guys, let's look at the previous step, guys, that if the derivative of one of the function does not give us the exact derivative of the other, guys, we need to use constants to make that possible. But note, friends, we should never use variables to make functions derivatives of other. We should never, guys. It's very important. We should never. Great, friends. Now that we've come to the end of looking at the introductory part, guys, let's look at now the main body of this video today. Great, friends. Let's look at the examples. The examples, guys. Now, friends, let's assume that we have the first question. We have the integral of 2x e raised to the power x squared dx. So, friends, in this case now, we see that we have two functions. We have 2x and e raised to the power x squared, right? Good. If we let our u to be x squared, you see that the derivative of x squared is 2x dx. Great. So, guys, let's let our u to be x squared. Good. We are letting our u because the derivative of x squared gives us 2x. Great. Friends, du gives us 2x dx, and it is exactly what we have here, guys, because we have 2x and we have dx. Great. If we make dx a subject, guys, by dividing all through by 2x, we are going to have our dx to be the same like du over 2x. Great. That therefore means, guys, this our integral now turns out to be just the integral of, we have 2x, our x squared is what, guys? Our u, right? So we have u here. Then dx is what, guys? du over 2x, so we have it here. But friends, what do you notice? That 2x and 2x are cancelling, right? So we are just going to have the integral of just e raised to the power u du. And as we saw initially, guys, e raised to the power u or e raised to the power x never dies. So integrating this, we are still going to have our e raised to the power u plus c. Great. But friends, what is our u? Great. Our u is what? X squared. So we are going to have everything to be just e raised to the power x squared plus c, guys. That's the answer. That's the answer to our question, guys. That's it. So let's look at the next question, guys. Hope you understood. If you didn't understand, guys, please leave in the comment section down below and I'm going to get back to you as soon as possible. Great. So let's look at the question 2 of it. So, guys, the question 2 wants us to evaluate the integral of x over x squared plus 1. Friends, keep in mind what I told you about when integrating fractions, that we want the derivative of the bottom to give us the top, right? Great. So in this case, guys, do you see that the integral of that, if we differentiate x squared plus 1, we are going to have 2x, but we don't have 2x here, right? So we can put a 2 here and put 1/2 outside. Great. That is the notion of using constants. So friends, in such a case, we are going to let our u to be x squared plus 1. So doing, guys, our du gives us what? 2x dx. Great. But we have just an x here, right? So we need a 2. We need a 2, guys. So what will happen now is that, or better still, guys, let's just make the, if we make dx the subject by dividing all through by 2x, we are going to have our dx to be same like what, guys? Du over 2x squared. So we are now going to take the integral from the x world to the u world. So we're now going to have now the integral of x. We have, what is x squared plus 1, guys? It's our u, right? So we have our u. Then dx gives us what, guys? Du over 2x squared. Friends, do you see that this x and this x, they are cancelling? Great. X is cancelling x, right? So we're going to have the integral of just our x cancels 1, x cancels 1. So we have 1 over u. Then we have du over just 2. Great. But friends, we have 1/2 here, right? 1/2 is a constant, so we can put it out of the integral. We can take 1/2 out of the integral, so we're going to have 1/2 times the integral of 1 over u du. Friends, what do you notice? We saw integral of 1 over u du initially, right? What was the result, guys? You guessed it right. It was the natural log of the absolute value of u. So the 1/2 multiplies it plus c. But friends, what is our u? Our u is x squared. So we are going to have 1/2 times the natural log of x squared plus 1. Keep in mind that we remove the absolute value sign because x squared plus 1, as you all know, guys, is always positive. It is never negative, guys. It's always positive. That's why we don't need the absolute value signs in this case. All right, that's the answer, guys. That's we are done. Let's look at question 2. Fine, let's look at question 2. The question 2 wants us to get the integral of the natural log of x over x dx. Great. So friends, in such a case now, we are going to let our u now instead to be the top because the derivative of natural log of x gives us what? 1 over x. We have the x in the bottom. So we are going to let our u to be what, guys? The natural log of x squared. In such a case, guys, du gives us 1 over x dx. We have x in the denominator, right? Which is what we have here. Great. So friends, in such a case now, we are going to make dx the subject. Making dx the subject means we multiply all through by x. We're going to have dx to be seen like, right, x du. Great. So we are ready now to take the integral from the x world to the u world. So our integral now, guys, turns out to be the integral of our natural log of x, guys, is what? Our u. X stays the same. What is dx, guys? According to this our relation, it is what? X du. So we have it, and x and this x can cancel, right? So we are going to have the integral of just u du. Friends, look at this as u raised to the power 1. Integrating that, guys, in the u world, we are going to add 1 to the power and divide by the new power as we saw initially, right? So adding 1 to the power, guys, we are just going to have 1/2 u squared plus c. But what is our u, guys? What is u? Natural log of x. So we are going to have 1/2 times the natural log of x, all that squared plus c. Great. That's what we have. So that's the answer, friends. That's the answer. We are done. Okay, now let's look at the question 4, guys. Let's look at question 4. The question 4 person who want us to integrate 2 sine of x over 1 plus cos squared of x dx squared. So friends, you notice that if we let our u to be the bottom, the derivative of the bottom will not give us even something that resembles the top, right? It won't. So guys, but keep in mind that sine and cosine, like I said initially, are best friends in integrals, right? So now, do you see that if we differentiate cos of x, not cos squared x, guys, if we differentiate just cos x, we are going to have sine x. Good. So guys, let's let our u to be what, guys? Just cosine of x. So we'll let u to be the cosine of x, guys. It therefore implies du gives us what? Negative sine of x dx. Great, that's what we have, guys. You have that. So if we make dx the subject, guys, by dividing all through by negative sine x, we are going to have our dx to be the same like negative du over sine of x squared. So friend, this our integral now turns out to be just the integral of sine x stays the same. Then we have 1 plus cos x is what, guys? Our u. Since it has been squared, we are going to have u squared. Then friends, what is dx? Dx is what, according to the relation, is what? Negative du over sine x. Do you see that sine x is cancelling sine x? Great. When that happens, guys, and we have a 2 here, right, and a negative, so they can go out of the integral. So we're not going to be having now negative 2 times the integral of 1 over 1 plus u squared du. As we saw earlier, guys, what is the integral of 1 over 1 plus u squared du? Great. Is arctangent of u, or tan inverse of u. So we are going to have negative 2 times the tan inverse of u plus c. But what's our u, guys? What's our u? Cos x. So we have negative 2 times the tan inverse of cosine of x plus c. Great. We are done, guys. That's the answer. We are done. All right, friends. If there's something you're not understanding, guys, please feel free to leave in the comment section down below. Just put it as a comment, and I'm going to get back to you guys as soon and as earlier as possible, even before you notice. All right. Let's look at question 5, guys. Let's see question 5. Question 5 is saying that we should evaluate the integral of 1 over x plus the square root of x dx. All right. So friends, what do you think we can do in this case, guys? What do you think? What do you think, guys? What do you think? Wait. So friends, we see that we have the integral of 1 over x plus square root of x, right? So friends, in most functions, you might not have the derivative of one part giving you the exact derivative of the other, but there's somehow that you can make things happen. Okay, you can make things happen sometimes. So we see that we have a very easy function such as x, and we have this complicated function square root of x, right? So guys, in such a case, guys, try to let u to be that part of the function that looks complicated, great, which is square root of x, right? So we're going to let our u to be the square root of x. Guys, in this case, we are going to square both sides because we want to get x by itself so that we can differentiate easily. So squaring both sides, guys, gives us our u squared. That's squaring both sides of this equation, we're going to have u squared to be the same like x, guys. In this case, guys, we differentiate. We are going to have differentiate u squared, guys, gives us 2u du because we're differentiating with respect to u. Differentiating 1 in the x1, guys, gives us differentiating x in the x1, guys, simply gives us 1 dx squared. So guys, this our integral now turns out to be we are definitely going to have the integral of u squared plus u. Friends, what is x according to this our relation? It is u squared, right? That's why we have the u squared. What is square root of x? U. So we have u. What is dx, guys? Is what? 2u du. That's why we have it here. But friends, we can factor u in the denominator to have the integral of, we can put the 2 outside since it's a constant. We have u up, which is this u. Then we have du here. Then we can factor u in the bottom to have u into u plus 1. But this u and this u, they can cancel, right? So we are going to have 2 times the integral of just 1 over u plus 1. Friends, you notice that u plus 1 is a linear factor, right? It's a linear factor. And integrating this, guys, simply gives us the natural log, okay? In such a case, guys, it gives us just the natural log of the absolute value of u plus 1. Great. But what is our u, guys? What is u? Square root of x. So we're going to have 2 times the natural log of absolute value of the square root of x plus 1. Great. So friends, in such a case, if you don't include the absolute value sign at this point in time, guys, it is still correct because this square root of x is always a positive function and the plus 1 means everything is positive. Okay, yes, so you might decide to leave it aside for now. All right, so friends, let's look at question 6 because we're going to be doing 13 questions in this our session. 13. Let's look at question 6, guys. Let's go ahead and look at it. Okay, friends, the question 6 of our problem is simply saying that we should get the integral of 1 over e raised to the power x plus 1 dx. Great. So friends, in this problem now, guys, we see that the equation looks almost empty, right? It looks almost empty since we're having ones everywhere, ones. So friends, in such a case, you see that the derivative of the bottom will not give you the top, right? Because if you differentiate e raised to the power x, you still have e raised to the power x. Integrating still gives you e raised to the power x, and so on and so forth, guys. So nothing seems to be changing. But friends, in such a case, we are going to multiply top and bottom by e raised to the power negative x, and trust me, guys, it's going to work out so nicely. Great. So by so doing, guys, we are going to have the integral of e raised to the power negative x on the top over e raised to the power negative x into e raised to the power x plus 1. Remember, we are multiplying top and bottom by e raised to the power negative x. So friends, multiplying these guys out, we are going to have the integral of just e raised to the power negative x over 1 plus e raised to the power negative x. These two guys gives us 1. Great. X. So in such a case, guys, if we cannot let our u to be what, guys? The bottom, right? Because differentiating this gives us what? Negative e raised to the power negative x dx squared. So guys, we're going to let our u to be what? The bottom, which is 1 plus e raised to the power negative x. Differentiating this guy du gives us what, guys? Negative e raised to the power negative x dx. But friends, we have e raised to the power negative x, right? We don't have the negative, so we are going to put a negative. We are going to put a negative here and also put it outside, so that negative times negative gives you positive. Great. So we are going to put a negative here and outside, so we are going to have negative of the integral of negative e raised to the power negative x over this, because this negative can multiply this one to give us positive. Everything is held the same. Great. So guys, do you see that we now have negative e raised to the power negative x dx, which is what? Our du. Great. So guys, that therefore implies we are just going to have negative of the integral of just our du over 1 plus e raised to the power negative x, what, guys? U. That's what we have, friends. And integrating 1 over u du, guys, as all know, guys, is what? Natural log of the absolute value of u. But since this guy is always positive, we don't need absolute value sign. So we're just going to have negative natural log of u plus c. But what is our u, guys? Our u is 1 plus e raised to power negative x. We are going to have negative the natural log of 1 plus e raised to power negative x. We have plus c. Great. That's it, guys. That's it. Hope you found it interesting, guys. Let's look at the next part. So for instance, I'm sorry for this boundary. Okay, I'm sorry. I'm super sorry, guys. Please forgive me. All right. Let's look at the question 7. Question 7 is simply saying that we should evaluate the integral of e raised to the power x plus 1 over e raised to the power 2x plus 1. Great. So friends, at this point, guys, I know you guys might be stuck on what to do, right? Great. But I'm going to show you guys everything. All right. So friends, let's look at this. In this case, we see that if we take u to be the bottom, du will not give us the top, right? Keep in mind that the power of this e raised to the power 2x will never change. Okay, it remains like that. No matter how you differentiate, integrate, it never changes. So let's, in such a case, guys, let's try to split the integral into 2 pieces. Let's have the integral of e raised to the power x plus 1, of e raised to the power x over e raised to the power x plus 1 plus the integral of 1 over just e raised to the power 2x plus 1. Friends, now that we have this said, in such a case, guys, we can therefore look at just this integral. Okay, let's just look at this one and see what we can do. Let's just look at the integral of e raised to the power x all over e raised to the power 2x, which can write as e raised to the power x all that squared plus 1. Great. Friends, what is the derivative of e raised to the power x? It's still e raised to the power x, right? Dx. Good. So we're going to let our u to be what? E raised to the power x, such that du gives us what, guys? Still e raised to the power x dx, which is what we have at the top. So in such a case, guys, we are therefore going to have now the integral of just 1 times du, which is simply what, guys? What is 1 times du is e raised to the power x dx, right? Because e raised to the power x dx is what? Our du, which is what we have at the top. Then e raised to the power x is equal to what? U. So we have it here, plus 1. Friends, what's the integral of 1 over u squared plus 1, as you saw initially? Is what? Arctangent or tan inverse of u plus c. But friends, what is our u? Our u is simply what? E raised to the power x. So we are just going to have tan inverse of e raised to the power x plus c. Great. Okay, now friends, let's look at this other part. Let's look at this other part in white. Let's look at it, because this answer is just the other. Let's look at this other part, guys. Do you see that this part, guys, resembles what we did in question 6, apart from the 2x? Great, guys, great. You can simply let your u to be this power and you proceed in this same manner. But friends, let's just do it as if we don't know. So in such a case, guys, as we did here, we are going to multiply top and bottom by e raised to the power negative 2x, as we did here for e raised to the power x. So we are going to have the integral of just e raised to the power negative 2x, multiplying it, guys, as we did here. We are going to have 1 plus e raised to the power negative 2x dx. In this case, guys, if we let our u to be 1 plus e raised to the power negative 2x, as we did here similarly, the u gives us what? Gives us negative 2 e raised to the power negative 2x dx squared. So friends, we need a negative 2 here, right? So we can put a negative 2 here and multiply outside by negative 1/2, so that they can cancel and everything remains the same. But friends, if we do all of that, you can do all of that following the same method we did here, guys. You're going to see that the answer to this, our entire integral, guys, is therefore going to be, so the integral of e raised to the power x plus 1 over e raised to the power 2x plus 1, guys, is simply going to die down into the first part, which is tan inverse of e raised to the power of x. Then doing this, guys, we are going to have negative 1/2 times the natural log of 1 plus e raised to the power negative 2x plus c. Great. That's it, guys. That's it. So friends, feel free to put your worries in the comment section down below, and I'm going to attend to it as soon and as earlier as possible, guys. Keep in mind that your success is my priority. Great. All right, friends, let's look at the question. Oops, guys, seems as if the numbering here is not correct, but let's just look at it. So I mistakenly wrote question 9 instead of question 10, guys, instead of question 8, but we are going to go by it so that we are not going to make mistakes. All right, let's look at this. Then the next question is going to be question 8. All right, let's look at this, guys. The integral of 2x plus 4 over 2x squared plus 8x plus 5. Great. So friends, what do you think we can do to evaluate this integral? What do you think, guys? So friends, if we have a fraction, guys, we are going to try by saying if a derivative of 2x squared plus 8x plus 5 is going to give us the top. Let's look at it, guys. Let's try. Great. So friends, let's give it a try. Let's just let our u to be the bottom and we hope for the best. Let's just let our u to be 2x squared plus 8x plus 5. That therefore implies, guys, du differentiating that gives us 4x plus 8. Since 5 is a constant, it gives us 0. So friends, what is the relationship between du and what we have at the top? Do you see that what is at the top is 2 times this? If we multiply this guy by 2, we are going to have this, right? So let's go ahead and multiply this guy by 2. And at the same time, we are going to divide by 2 such that everything stays the same. So we're now going to have now, guys, 1/2 integral of, you have multiplying everybody here by 2. We have 2 into 2x plus 4 dx, which is what our du. So guys, in this case now, since the top is just our du and the bottom is our u, so we're indirectly integrating 1/2 times the integral of 1 over u du. But friends, what is the net integral of 1 over u du, guys? We have been doing it so many times. It is what? That's great. The natural log of the absolute value of u. But what is our u, guys? Our u is simply 2x squared plus 8x plus 5. Great. That's our answer, guys. That's what we have. That's the answer. Great. So friends, let's now look at question 8 since we made an error and we looked at question 9 instead of question 8. So friends, the question 8 is simply saying that we should get the integral of natural log of 2x over x natural log of x dx. So friends, I got this question from the 2020 MIT B qualified exam. Great. That's where I got this question from, guys. So in such a case, guys, one mistake that most students are going to make is that they are just going to, since they have natural log of 2x, they are going to cancel natural log of x, cancel natural log of x here, and they're going to have 2 over x, guys, which is wrong. Guys, that's wrong. Okay, don't do that. All right, but friends, let's try. If we let our u to be the bottom, du will not give us the top, right? But friends, in such a case, let's try to make sure that the inputs are both the same. Here we have natural log of 2x, here we just have natural log of x. So let's make them to be the same. Let's use our log property to split this guy into 2. By so doing, guys, we are going to have the integral of just the natural log of 2 over x natural log of x plus the integral of natural log of x over x natural log of x. Great. We can cancel the natural log of x here, right? Good. So we are therefore going to have now, and ln 2 is a constant, so we can put it out of the integral since it's a constant. That's 0.699 and so on, guys. So that's it. It's a constant. Then we have 1 over x ln x dx plus the integral of 1 over x. Since natural log of x will cancel here. So friends, let's look at this integral, because this one is pretty cool, right? Pretty easy. Just for me, just natural log of x. That's it, guys. Let's look at this one, guys. If we let our u, guys, to be the natural log of x, du gives us what, guys? 1 over x dx. Great. That's what we have. And it is the same 1 over x we have here, right? Good. So in this case, guys, we are indirectly integrating what, guys? The natural log of 2 into the integral of 1 over u du. The integrated 1 over x, guys, gives us what? Natural log of x. Great. So friends, in this case, guys, we are going to have natural log of 2 times the natural log of u plus natural log of x plus c. But friends, what is our u? Natural log of x. We are therefore going to have now the natural log of 2 into, the natural log of x plus natural log of x plus c. Great. That's the answer, guys. That's the answer. Hope you found it useful, guys. Hope you found it useful. All right, now, guys, let's look at question 9. Oops, we did question 9 already, right? Great. Let's look at question 10, guys. Question 10 is simply wants us to evaluate the integral of sec to the power 4x dx. Great. So friends, you notice that this integral looks difficult, right? It looks difficult, but guys, I can guarantee you that it's very easy. Okay, all right. So friends, let's try to split this sec to the power 4x as the integral of sec squared x times sec squared x dx. Because multiplying these two guys out, we are going to have the same weight. So friends, at this point now, guys, let's look at this sec squared x as 1 plus tangent squared of x. We are going to have now the integral of 1 plus tan squared of x sec squared of x dx. If we multiply everything, guys, out and we split into 2, we are going to have the integral of sec squared x plus sec squared x tan squared x dx. So guys, in this case, guys, we notice that we could integrate sec squared x, right? It's very easy. So let's split the integrals into 2. So we have this. So friends, we can integrate sec squared x, right? It's very important. So let's keep it aside and focus on this guy. In this case, guys, if we let our u to be tangent of x, du gives us sec squared of x dx, which is what we have here. So you know that what, guys, we are simply going to be integrating sec squared x, guys, gives us tan x, as we saw that the derivative of tan x was sec squared x. So integrating sec squared x brings us back to the tangent of x. Great. So guys, our tan x is what? U. Since it's squared, we have u squared. Then our du is equal to sec squared x. We have it here. Friends, using the power rule of integration, we are going to add 1 to the power and divide by the new power. We are going to have tangent of x stays the same, plus adding 1 to the power and divide by the new power, we have 1/3 u cubed plus c. But what's our u, guys? Tan x. We are going to have the natural log we are going to have tangent of x plus 1/3 times the tangent cube of x plus c. Great. That's our answer, guys. Let's look at question 11, guys. Our question 11. We are going to be saying a definite integral at this point, guys, which will be going from 1 over square root of 2 to square root of 3 over 2 of x over x to the power 4 minus x squared plus 1. Great. So guys, if we differentiate the bottom, it will not give us the top right here. So we are going to do use sub, but not now. Okay, let's try to make it easy for us first before we can use sub. See that the power in the denominator looks too big, right? It looks too big. So we are going to let's try to reduce this function, guys. We can do a substitution. We can let our x squared to be the same like our v. Okay, that therefore implies, guys, our x to the power 4 is going to be equal to what? V squared. Great. That's what we have, friends. That therefore implies this our function now turns out to be v squared minus v plus 1. Oh, friends, I made an error. Here was supposed to be minus. Okay, please try to correct it. Here ought to be minus, not plus, please. So we have this, guys. So friends, let's try to complete the square. If we complete the square, guys, we are going to have v squared minus v. Completing the square simply means we are going to take the coefficient of the absolute value of the coefficient of this our v, which is going to be 1. We have it square, add and subtract. Great. So we have this. Friends, completing the square so well, guys, we are going to have our v minus 1/2 all that squared plus 3 over 4. Great. That's what we have, friends. Then now, in this case, guys, this our original integral now turns out to be the integral going from the same limits. But friends, what is our v? Our v is what? X squared. So we have our x squared back. We have all over x plus 3 over 4. Great. We've completed the square so well, guys. So how then do we proceed, guys? How then do we proceed? How then do we proceed again? So friends, do you see that if we take our u to be the inside, which is x squared minus 1/2, guys, du gives us 2x. We can just put the 2 here and put 1/2 here, right? Great. So let's give it a try, guys. Let's set our u to be x squared minus 1/2, such that, guys, du gives us 2x dx. Great. That's what we have. Then, friends, in such a case, now this our integral turns out to be, we need a 2 here, right? We need a 2 here, guys. So we can simply put a 2 here and 1/2 outside. So we're going to have 1/2 integral of, we have 2x. Since 2 and 2 they can cancel, we have the same thing of our original function. Great. So friends, in such a case, we can therefore say that this is just going to be, now we can change the limit, guys. We can change the limit. These are the x values, 1 over root 2 and square root of 3 over 2, guys. These are the limits of integrations, right? So we can, these are our x values, x. So when x is 1 over square root of 2, we put it here, guys. We are going to have u, right? We are going to have u to be what? 0, right? And when x is this, put in here, guys, we're going to have what? 1. Great. So this turns out to be now, guys, 1/2 integral from 0 to 1/2 of what, guys? Of, we have 1 over this. What is x minus, what is x squared minus 1/2? It is what? U. So we have u squared plus, we can write this 3 over 4 as what, guys? Root 3 over 2 squared. Great. Friends, the reason for doing so is that we want to use the arctangent formula, which simply states that from the arctangent formula, guys, the integral of 1 over u squared plus a squared is equal to what, guys? 1 over a times the tan inverse of u over a plus c. Our u in this case remains u. Our a is what, guys? Our a is square root of 3 over 2. Good. So in such a case, guys, applying the same thing, we are definitely going to have have 1/2 integral of our function, which is simply going to give us, keep in mind that, guys, this 1/2 stays the same. Dividing this guy by taking 1 over this guy simply means 2 goes over root 3 comes down, right? But the 2 and this 2 here, they can cancel. Good. So we are definitely going to have just 1 over root 3. Since this 2 will cancel with this 2 on the bottom, then tan inverse of, we have our u over a. But our a is what? This, right? Dividing this guy simply means moving the 2 to the top, and the numerator goes down to the denominator. That's what we have, friends. But the limits of integration, guys, are from what? Are from 0 to 1/2. Great. That's what we have, friends. So if we plug in everything, if we plug in the upper limit minus lower limit, keep in mind the upper limit is 0 and tan inverse of 0 is simply 0. So we just care about the upper limit. So we are going to have 1 over the square root of 3 into, plug in 1/2 here, guys. We are going to have 2 into 1/2, which gives us 1. So we have 1 over square root of 3 inside the tan inverse function. And that result, guys, simply gives us pi over 6 or 30 degrees, but always put in radians, always in radians, guys. Then plugging in 0, we are going to have 0. So if you rationalize the denominator, guys, and simplify, we are definitely going to have square root of 3 over 18 pi. That's the final answer, guys. That's the final answer. So friends, please don't forget to like the video, friends. Give it a thumbs up. Subscribe to this channel if you want more great content, guys, because it really motivates me when I see so many subscriptions. Great. Okay, friends, let's look at those two, question 11. Let's look at question 12, guys. Awesome, that's great. Let's look at question 12. Then we are going to end with question 13. Great. So question 12 wants us to get the integral of sine inverse of x over square root of 1 minus x squared dx. Hey friends, don't be scared, okay? Let this function not scare you, okay? Because it's actually the cheapest. It's actually very cheap, guys, very cheap. If you are going, if you get scared, guys, it will be very difficult for you, but I promise you, guys, it's very cheap. Friends, you notice initially, guys, the first part of the video, the first slide, I said the derivative, that the integral, that the derivative of sine inverse of x is what, guys? 1 over 1 plus 1 over square root of 1 minus x squared, right? Good. So we're going to let u to, in this case, be the top. We're going to let u to be sine inverse of x, such that du, guys, gives us what? 1 over square root of 1 minus x squared dx, which is what we have here, guys. So friends, it therefore means that our du is equal to what? This, right? So we can write this integral as what, guys? As the integral of sine inverse of x times 1 over the square root of 1 minus x squared, because if they multiply, we have the same function. In this case, guys, we consider sine inverse of x is what? U, right? Then 1 over square root of 1 minus x squared is what? Is this, right? Great, it's just our du. So replacing everything, guys, we are going to have the integral of sine inverse of x is what? U. What is 1 over square root of 1 minus x squared dx is du, so we have it here. Great. Apply the power rule, guys. Adding 1 to the power and divide by the new power. The power here is 1. Doing that gives us 1/2 u squared plus c. But what's our u, guys? Our u is sine inverse of x. So we have 1/2 the sine inverse of x, all that quantity squared plus c. Note, guys, note, important note. This is where most of my students have been making errors. Note, friends, that sine inverse of x, all that squared. Super sorry, friends, super sorry. So, friends, sine inverse of x, all that squared, is not the same like sine inverse of that is not the same like sine of negative 2x. Okay, keep in mind, guys. This point is very, very important, guys. Keep in mind they are not the same. Don't ever mistake them. All right, let's see question 13, guys. Let's look at question 13, which I presume was the most difficult. We have the integral from 0 to pi of x sine x dx. So, friends, so many students might still get this problem done using the method of integration by parts, but I'm going to show you guys a method which is still the u substitution. So in this case, guys, we are going to let u to be something slightly different. Each time you have a function, that's a normal linear function such as x, which is multiplying a separate function such as a trigonometric function, and the interval, guys, is from 0 to pi. Sometimes it can be from pi to 2 pi and so on, guys, or sometimes from 0 to 2 pi, guys. Always think of this method. We are going to let our u in this case, guys, we're going to let our u to be same like pi minus x, which is the interval here, pi minus x, such that, guys, our x becomes what? Pi minus u, right? If we differentiate x, we have dx will be like what, guys? Negative du. Great. So this is our integral now. This is our original guy now translates into. So we have the integral now of x sine x dx, which gives us, guys, when these are the x value, the intervals are the x values. So when x becomes 0, we plug in 0 here. Our u becomes what? Pi. When x becomes pi, put in here, guys, our u becomes what? 0. Keep in mind that dx is what? Negative du. So we are going to have now negative of the integral from pi to 0 of what is x, guys? X is pi minus u. So we have it here. Then, guys, we just use f of sine x if this is a function of sine x, right? But the f is not important, so you can take the f out. So we just have sine into our x is what, guys? Pi minus u. So we have pi minus u du. That's what we have, friends. So, friends, in such a case now, this integral therefore translates now into, so we have the integral of pi, the integral from 0 to pi. This can go into integral from 0 to pi, right? Because we can use the negative sign now, guys, to flip the limits of integrations. Okay, we can use this negative sign now to flip it. These are one of those properties of definite integrals. We can use the negative sign to flip the limits of integration. So we have the integral now from 0 to pi of just our function. Great. So, guys, in this case, friends, all we are going to do is that we are going to replace we are therefore going to multiply out the brackets. Okay, multiply the bracket. But, friends, what is pi minus u? Friends, what is pi minus u? Is what? Our x, right? Friends, keep in mind that x and u in this case are dummy variables, so we can replace their values when necessary. So this guy turns out to be now, guys, the integral going from 0 to pi of, if we multiply everything, guys, if we multiply out the brackets and replace all the u's back with our x, we are going to have the integral of pi sine of x minus x sine of x dx. Great. So, friends, you notice that if we split the integrals, this integral is going to be the same like this one, right? So if we bring it out to the right hand side, we are going to have two of them, right? This plus this, we have two of them. So we're now going to have 2 times the integral from 0 to pi of x sine x, which is the same like what? Pi. Pi is a constant. We can put it outside as we have here, from 0 to pi of just sine of x. Oops, guys, it was supposed to be the x here. Great. So, friends, if we divide all through by 2, we have the integral going from 0 to pi of x sine x equal to, you have pi over 2 integral of sine of x, great, dx. All right. So, friends, The integral of sine x, as you all know, guys, as we saw initially, the first slide of the video was what, guys? Great. Negative cosine of x. Great. So we have that to be the same like what, guys? Negative cosine of x. Limits of integrations are from 0 and they'll be ending at where? 2 from pi. Great. That's what we have, friends. So if we plug in everything, guys, we are definitely going to have our answer to be pi over 2 as the answer. Great. So, friends, that is it. That's it for the video, guys. That's all about the video. So, friends, watch out now for the full lectures about integration by parts, which has been made extremely easy, guys, for you. So, friends, as always, make sure you press the subscribe button if you're not subscribed, guys, because if you don't subscribe, guys, you are not going to be having access to all our contents, guys. Or better still, guys, you might not see me again. Maybe this might be the first or the last time you're seeing me, guys. If you want to see me the more, if you want to get my lectures and learn and pass any exam you intend to pass, because that's my promise, make sure you hit the subscribe button if you don't subscribe, guys, and press the like button, guys, because it motivates me to keep producing more great content. Please place your worries in the comment section down below. If the video was good, guys, comment that it was good. If it was bad, guys, bring forth solutions that we can make the video good next time. Thank you and have a blessed day.